In this lesson, there's an added layer to the word problems that we were working on yesterday. So here we're going to be talking about angle of elevation and angle of depression. So if we're looking for the angle of elevation, that is the angle created by the line of sight of the observer in the horizontal for an object above the horizontal. Basically, what angle do you have to look up, right? So if you're starting at a horizontal, right, you're normally looking right here are your eyeballs, and this is where you normally look. If you wanted to look, for example, up at a plane in the sky, you would have to tilt your head and create an angle of elevation. This is compared to an angle of depression, an angle created by the line of sight of the observer. So again, you're here, standing. Here's your line of sight. And a horizontal line for an object below the horizontal. So then you're saying, okay, how far do you have to look down, for example, at an ant on the ground? This would be your angle of depression. So for example, Avery, whose eye level is 1.5 meters above the ground, so he's looking here, this is his normal line of sight, stands 30 meters from a tree. The angle of elevation of a bird at the top of the tree is 36 degrees. So that's saying that if he wants to look up at this bird, it is going to have to move his head 36 degrees. How far above the ground is the bird? So if we look, we now have formed a right angle. So we have a right triangle. Right? Avery is 1.5 meters above the ground. And he is 30 meters from the tree. Right? We're asked how far above the ground is the bird. So the bird, we're looking for this whole distance. So I need to find the vertical distance. This is what I'm looking for. Then I also have to make sure that I remember that this is 1.5 because Avery is 1.5 meters above the ground. So if I look at 36 degrees, right, 30 is my adjacent, x is my opposite. So, ka, toa. I don't have the hypotenuse, so I'm going to be using tangent of 36 is equal to my opposite x over my adjacent 30. Cross multiply 30 times tangent of 36. Now you plug into your calculator. 30 tangent 36 is equal to 21.796 ... Now you don't want to round until the end for these problems. You only round once. So this is the distance here. I want the total distance, so I now have to add 1.5. So just in your calculator, hit plus 1.5. And your final answer for your total distance will end up being 23.296 ... And if we round that to the nearest tenth, that'll be 23.3 feet above the ground, right? Because again, when we're using the trig, we're using the trig to find the distance here between the bird and Avery's line of sight. You then also have to add how far above the ground Avery is as well. So now for number 2, from an angle of depression of 40 degrees, Leah watches her friend approach her building from standing on the rooftop, right? So Leia's normal line of sight is here. If she wants to look down at her friend coming up, she would have to look down 40 degrees. And this is how we get our right triangle for this problem. The rooftop is 16 meters from the ground, and Leia's eye level is about 1.8 meters from the rooftop. What is the distance between Leia's friend, and the building? So I'm looking for this distance because I'm looking for how far Leia's friend has to walk, right? Now they're giving us vertical distance. They're saying the rooftop is 16 meters from the ground, and then Leia's eye level is 1.8 meters from the rooftop. So this whole distance is both 16 plus 1.8. which gives us 17.8. Right, so like how in the last one we had to add at the end, here we're adding at the beginning in order to set up the correct triangle. So I have 40 degrees, I have my opposite, and I'm looking for my adjacent. So I am again going to use tangent of 40 is equal to my opposite 17.8 over x, my adjacent. Now when I cross multiply, I have x times the tangent of 40 is equal to 17.8. Now because x is not by itself, I have to divide both sides by tangent of 40. So in your calculator, all you're doing is 17.8 divided by tangent of 40. And you're going to get 21.2132 ... And if I tell you to round it to the nearest tenth, it should be 21.2 feet. Now if we look at number 3, it says find the distance between the two boats based on the diagram below. So I want to know what is the distance between these two boats, right? So I have to look and see what right triangles I have. So for instance, if I look at my first one, here's my right triangle. They tell me that the entire vertical distance is 112. This angle right here is 6. So I have 112, which goes all the way to the bottom. So there's a 1.5 feet here, so I have to subtract 1.5 feet. It's not going all the way. So I have 110.5 is my vertical distance. So now because I'm worried about the horizontal, let me figure out this distance, my adjacent. So I have tangent of 6 is equal to 110.5 over x. Same thing we did with the previous one. You're going to have to divide 110.5 divided by tangent of 6. So we have 1,051 feet. I'm just going to round it right from my calculator. Now I want to know, so I have this whole distance. If I want to know what this distance is so I can subtract, I'm going to have to do the same thing. However, my angle for this triangle is going to now be 49 degrees. Excuse me. Yeah, no, it's going to be 49 plus 6, which is 55 degrees. So now, tangent of 55 is equal to 110.5 divided by x. I'm going to do the same thing, but for the sake of time, I'm just going to do 110.5 divided by tangent of 55, and I get 77.37 ... X is about equal to 77 feet. And so if this is 77 feet, and the whole thing is 1,051, I do 1,051 minus 77 to get 974 feet. And now we have some more practice problems. Brian's kite is flying above a field at the end of a 65-meter string. The angle of elevation measures 70 degrees. How high is the kite above Brian's head. So because it's saying above Brian's head, you're not going to have to add anything. You're just going to do a straight trig problem. So we're going to say, since we're doing opposite, so it's sine of 70 is equal to x over 65. So 65 times sine of 70 is 61 feet. From an airplane at an altitude of 1,200 meters, so altitude is vertical distance, the angle of depression to a building on the ground measures 28 degrees. Find the distance from the plane to the building. So here we're looking for horizontal distance. I don't think we can solve this one. This is not... Yeah, just skip this one. There's not enough information about the building in order to solve it. From a point on the ground 12 feet above the base of a 12 feet from the base of a flagpole. So we have a flagpole, 12 feet. The angle of elevation to the top of the pole measures 53 degrees. How tall is the flagpole? So here, tangent of 53 equals x over 12. Plug it in your calculator. X is equal to about 15.9. For the sake of time, I'm just going to skip to the regions problems. An airplane took off at a constant angle of elevation. After the plane traveled for 25 miles, it reached an altitude of 5 miles. To the nearest tenth, what was the angle of elevation? So here, we're looking for the angle here. So this requires you, in order to recognize what angle of elevation means. So since I have opposite or an adjacent, it's sine. So 5 over 25. X is equal to the inverse sine of 5 over 25. So x is equal to, so we're doing to the nearest tenth, 11.5 degrees. The diagram below shows a ramp connecting the ground to a loading platform 4.5 feet above the ground. The ramp measures 11.75 feet from the top of the loading platform. So we're looking again for the angle of elevation. I have opposite and hypotenuse. So sine of x is equal to 4.5 over 11.75. So again, 11.75. So we're doing x is equal to sine inverse of 4.5 over 11.75. And I get x is equal to 22.5 degrees.